Alright, so, hi. My name is Ninyo Rabuni Bimadangit. I'm from 27BSIT Citas, Mechanical Technology. Today we're going to be discussing about Newton's Law of Motion. And today I'm going to be discussing inertia. What is inertia basically? So our objective here is to know what is inertia, why is inertia, how is inertia, and basically when does inertia affect it. So the basics, right? Inertia is basically a constant motion if it's not applied by an external force. So let's get the basics down. We got mass, we got a direction upon which it travels, and it will continue on traveling no matter how fast it goes. So to further explain what I'm saying, here's a video of me just playing with water and just running around with water. And you might question, why is water representing inertia in a bucket, in a square bucket? Well, as you can see, I move forward and stop suddenly, yet the water keeps moving forward and backward. Well, obviously, if my bucket was longer, it would continue moving forward until it would stop on the other end. But it's important to note that the water keeps moving forward until it stops on a barrier, meaning inertia is applied. Do you think that is absurd as an explanation or a presentation? Let me show you. We'll critically analyze this video here. Okay, so again, I will play it again, right? And it's weird that when it reaches the edges left and right, I already stopped going left, and yet the water keeps motioning that it wants to go left, but it's only blocked, and it even spills out of the bucket just to go further left, meaning that I have solved the problem of friction by using water as an object that keeps moving no matter how much distance or blocking is it applied. Now I'll go that again, and as you can clearly see, even when I keep moving, it still just keeps getting disturbed, meaning there's a lot of inertia going all around these places, and it continues to splash around, meaning inertia is being applied to the water, and the water has its own mass, aka weight, to keep moving forward to that direction, obviously even all around, which makes it better because it's a clarity and it's a uniform object that will keep splashing around no matter what direction you're moving towards or coming back from. So another example here is basically a car stopping. Let me show you. So as you can clearly see here, as you can see, the car is trying to do the meme, right? But behind the meme is a good representation of inertia. As you can clearly see, the driver steps on the pedal 3 times and moves forward and jitters forward. Notice how the back keeps moving forward, yet the front stays grounded, at least until it keeps moving because not enough friction is applied. Alright, so if these examples didn't convince you otherwise what inertia is, well, law of inertia is an object will preserve its state of motion unless acted upon an external force. Remember, if the net force is not 0, then there is motion for the technical reasons, right? Because, you know, the magnitude or the vector and all that such. And if it's 0, there is no motion. So that's the technical side covered. Thank you. This is inertia, basically. The car was moving at an acceleration, and its weight kept it going there, and then the sudden stop of the brakes wasn't enough to stop the inertia from going forward. Thus, the back was, throwing it back, going up, and then it did the meme. He pedaled on it 3 times, therefore Nico Nico Ni. So, simple explanation. So, in conclusion, what did we learn here? Inertia is basically mass going at a direction, and if not affected by external forces, it will keep going in that direction. AKA, if you launch a something at space, it will keep going in that certain direction until it's stopped by an external force. Thank you.